to ask about like, okay, well, how does this work? What is this function? What does like how did you know to use that function in that place, for example? So what the heck? Oh, sorry. I moved everything around on my computer yesterday. I guess I can just, even while I'm figuring this out, I'll share my screen. So it doesn't, you're not just looking at nothing.
So the library. So the library that we're going through today is, I don't know if you said this already, Kyle, but persistent.
Yeah.
It's a FRM you mentioned, functional relational modeling.
So this actually is a layer before that. The one that we typically use is, if everyone's heard of like the term ORM, object relational model, it basically just like models all of your, I guess you could kind of call this an FRM, but like it gives you, actually, you know what? I digress. It is. There's a very fine line between what's just kind of like a uh, they call it DAO, like a data access, or DAL, data access layer, and what's actually a functional relational model. Um, and so this will actually model all of our relationships for us in types. And so I'll get into what that means in a second here.
If am I correct that it's the example you showed me about like when we were talking about persistent?
Yeah,
Just okay, cool.
yeah,
So yeah,
yeah. I just changed it a little bit so that it wasn't, because that was something for a previous client. So I just kind of removed all that.
okay. So just a synopsis of what we're going to be going through today. Key like concepts to look out for. Um, so we'll come across like how to do like error handling. So like when stuff goes wrong, how do we model that in Haskell? Because although we're talking about like name error and that sort of thing, we're not talking about like those kind of errors. We're modeling like like for example, what if we're looking for something in the database but it does not exist? What do we do then? How do we model that with Haskell so that our code is still bulletproof? And bulletproof doesn't mean that the user will never make a mistake or that the state of the world will always be as we expect. But sometimes it might not be as we expect, and so we want to make sure that we handle those cases. So Haskell is amazing for making it really easy to model that and make like kind of bulletproof code with that. Just trying to think too. Yeah,
Yeah,
cut me off at any point, Kyle. But
yeah. I'm gonna cut you off now because
cool.
I'm ready to go.
Heck yeah.
Um, just see if I can everyone see this? I think I'm gonna zoom in and make it a little easier to see.
Are you sharing your
Are you
screen?
sharing the screen?
I'm supposed to be. Guess not. Give me a second.
Don't think you are, my friend. There we go. Oh, it's gone.
Uh-oh.
It came up for a second and then it stopped.
Yeah, I saw that. The demo gods are mad today. Oh, I shared the window. Maybe something happened with the window when I resized it. Let me just share the screen.
There we go.
Yeah.
Now we are good to go.
Give it a second. All right, still going. All right, so I'm starting with just like a absolutely base project. Like there's nothing here. We're actually going to just start right from the Nix file. So if anyone remembers from last lesson, we talked about Nix and how it's, if you've ever used like It's basically a package manager mixed with a container manager. Like it's basically, if you've done any kind of programming, it's like npm mixed with Docker is probably the best way to say it. But it's also got like operating system level, like more operating system level features. So like things on your operating system are actually modeled as packages as opposed to just writing shell scripts. So it's a really valuable tool to learn because it makes your entire environment declarative. And what that means is, like, if it works, they always, there's the joke like, well, it works on my machine, right? And then, someone else's machine, it doesn't work. The idea behind this is that we're putting everything behind a shell that if you run it within that shell, it will work, right? Because it's exactly the same environment. And the entire environment is held within the Nix store, which is basically just a cache of all your packages. So I'll start there. There's like command line tools and stuff to like make defaults of these files, but I'm just going to type them out. And I have like mostly everything on the side here, so we won't spend too much time typing. But first thing that we're going to do in any shell script, we have our this. I like to start with the shell.nix. And this basically just allows us to create a runtime shell. So for what we're going to be doing, we're going to need these two, which you've seen before, Haskell packages.gac and Haskell packages.cabal install. But today we're actually going to be using Cabal, so you'll be able to see what Cabal does. Previously, we hadn't imported any packages or anything, so we were just not really using it. I guess we were using it to compile, but not to actually pull in any packages. We're also going to be using PostgreSQL and zlib, and I'll quickly just jump to show you like where these packages come from, because I think that's important rather than just assuming that they're magical packages. So if we go to NixOS search, I can never remember, search.nixos, you can search for a number of things in here. Like you can even search for Discord. It's got Discord, right? You could search for Postman. It's got Postman. So like these are quite literally like applications that are packaged up into what they call Nix derivations. And so, for example, for our application, I want Postgres. And so you can see here all the different versions of Postgres. Postgres is a database. For those who aren't familiar, it's a relational database. And so here's a package, and it can show us how to install it. We can either use Nix shell-p, or we can add it into our actual package build inputs for the packages here. And you can see here that packages is imported from Nix packages. Zlib is just a dependency of Postgres. I'm adding it in to save the time. Basically, if you were to run this without zlib, it would just tell you that it needs zlib, and then you'd have to run it again. So in order to save time, I just know it's there because I've run this before. And then we can do something kind of cool with this is we can add a shell hook. And so this is where we're actually going to set up Postgres. There are other ways of doing this. Like later on, we'll show you some frameworks that kind of manage this for you. But it's kind of important to just show like what you can actually do to set up Postgres in a declarative manner, rather than just kind of installing it. I mean, you're probably fine to just install it, but this is kind of just the way that things happen in Nix, is that we want to do everything declaratively.
Cool. When does that run? The shell hook.
Shell hook runs as soon as you open Nix shell.
Yeah.
So first thing it does is it pulls in build inputs, and then it'll run the shell hook, whatever you put in here. And the language that's inside of here is Bash. So if this is basically the language that allows you to interact with the operating system. If you've done any like coding in your terminal, you might recognize some of these commands like make dir, You could do like CD in here, ls. Like this is basically just like a terminal, but in a script. And so it's going to allow us to do a number of things. A lot of this stuff you just find by doing like looking through Postgres documentation, even admittedly using something like ChatGPT. It's very good at like, how do I configure this? And then you kind of just work through some of the because at this level you're working with your file, you're working with the file system that is inside of this Nix shell. And so, there's going to be certain things like ownership of files. Some files aren't executable, et cetera, et cetera. And so I basically just changing the ownership of these files. Don't worry too much about this. I am going to provide the code at the end of the lesson.
I'll even say too, like this is why we use Nix. Like you'll see for the projects that we have, like Nix files set up for you, and these are meant to just work. Like
Yeah,
so the most complicated factor, which is hopefully not complicated at all, unless maybe you have any issues here, is downloading Nix. But once you have Nix installed on your system. And so, like, if you have Windows, the one caveat is that you'll want to use WSL.
yep.
Um, so
Which is
that might,
actually what I'm doing right now.
yeah. And um, so if you have any issues like running Nix, like whether that be installing it on WSL or in general, let us know because we are here to help. We want that to be like the easiest process of all, so that you can literally just do what Kyle's doing here. If you have no idea what just happened, you could do Nix shell here, and then boom, you're ready to start writing
Yeah,
Haskell.
yeah, yeah. So the idea is you write it once and you never touch it again. So here I'll do Nix shell, and I just hope. Oh, I've got a syntax error. What am I forgetting?
Semicolon. Or oh yeah, there.
Yeah.
Come on, Kyle. You forgot a semicolon. I thought you were a perfect developer. Never made a typo mistake ever.
No, we always make mistakes.
Exactly.
Oh, running as root. Yeah. So this just a detail. Postgres can't be run as a root. For security reasons, they want you to actually create a user that has access to Postgres because there's a lot of, yeah, we won't get into security too much. There's reasons for this. So I'm just going to log in as my user that I created. This was actually giving me problems yesterday, but we got it. Hopefully this works. So we'll go into Haskell examples, DB serialization. Okay. Now I will try again. And I actually added that, so it'll tell you if you're running as a root. Okay. Fatal Postgres. Role Postgres does not exist. Oh yeah. Okay. Gil install for a minute.
Cool.
We've so basically it seems there's an issue. Connection to server.
The user Postgres does not exist. Do you have to like set the? Yeah, I think role just means user. No, or
Yeah. Log file already exists. I think this is still using something outside of the Nix environment.
well, so I noticed that you're using PSQL, like on line 43, if exclamation mark PSQL, you can like I forget the syntax of it. I think it's like the double brackets. It's almost like a bash variable. and you can make sure that you're using the bash, like the PSQL that you have passed in. So
Okay. Going to just give it a second to get this working here. This is probably one of the most common issues that you're ever going to run into with any Linux coding is user permissions. And it seems to be an issue with the, like my user, like, so this, okay. Nix will handle the environment itself, but it doesn't actually handle my local file system. So like if I don't have permissions to access something, I still don't have permissions to access something. That's actually something that's one of the big benefits of using what's called Nix OS, which is like an operating system built in Nix. Whereas like when I'm using Linux, I still have to deal with some of this. Okay, just give me a second. I gotta.
yeah, I could even do a little quick blurb on either. I think that would be like a useful use of time. That would give you like a couple minutes to debug.
Yep.
Okay,
Do
cool.
you want to? Do you want me to hand over the screen or what?
I'll take the screen, sure. Yeah. Let me just. Cool. Okay. Lauren, is my screen visible?
Indeed, it is, my friend.
Cool. So I just wanted to take a little quick snippet of time to talk about either. So like, although we don't have the database yet set up, we can, we can still like think about how do we handle this problem. Um, so like let's say we're running a database query where we are going to we're going to be looking for a user based on their email, um, and check if we can log them in basically. So that we have their email, we have I'll write it first like it was like Python or something. We have their email, we have their password, and we want to get back the I think in Python it's actually technically this. So I'll say that this is TypeScript here. So email and password, and we get back a logged in auth cred or login auth cred, we'll call it, whatever that looks like. So how do we do this? We would first want to check if can we find the person by email, and then check their password. Yeah, so first we're going to search for a user based on email. And then we're just going to check the password. So password 1 equals password 2. The password passed in is equal to pass 2. And so how we would actually like write this in Haskell is that we would say, let's say we're writing this in Haskell as if it's like another language, and we're not aware of how either works yet. We're going to write login user, and this is going to be the type email and password, and it'll give us back a auth cred, we'll call it. So an auth cred, I'm going to use I'm going to use this type keyword just to make things easier to read. So this is saying that email is really just a string. Same with password. Password is really just a string. And authcred is actually just their user ID. So we'll just call it an int for now. In reality, this would be like like signed, like hashed, so that only they can dehash it. And that is actually how like any auth system works. Is just that you have some sort of like user identifier which is hashed, and only they can unhash. Of course, there's OAuth or whatever, but even OAuth is effectively just doing this under the hood for us. So, okay, we get our auth cred back. I don't know why I deleted it there. And great. Email pass. And so we'll have our pseudocode here, which is going to say, so we're going to use do syntax, which just allows us to do like a bunch of actions in a row. And because I'm using do syntax, if you're not sure how to use do syntax to start with, like you probably want to use do anytime that you have IO here, and that's real safe for now. You'll understand that better as we get more deep into the discussion and the lessons. The lessons also do help you understand at a deeper level what we are doing with do and IO. But here, let's say look up user, and we'll take their email and some DB connection string, we'll say, and DB connection string is just going to be a constant that I've set that is equal to my local Postgres. So it's probably gonna look like if you're using a connection string, it probably looks like this, or it's like Galen at my password Postgres. Then it'd be the port, and then my DB name. So I'm gonna call it this instead. So this would ultimately try and look up the user. Obviously, we haven't written the logic of how the lookup user works, but we will probably see that with Kyle's demo. And so what happens if this fails or succeeds? So obviously, if this succeeds, we're all happy. We get back a user, and we're like, yay, okay, now we check password. Again, this is all pseudocode here. Check password, pass in user. So this is gonna just simply do this, where we have the password and the user. And so yeah, I guess this will also just here. And so let's say our password is this, and we have our user, which we're going to use some Haskell data type that user contains for some reason our user just has a password. So the string is representing the password, and actually I'm going to say user password because I can use this type of defined here. And I guess we'll just say pass is equal to their pass. And then if that's the case, if check password, this is actually going to be a bool because because we're checking if it's true or false. If check password, then return their user. Else, oh my gosh, this is so ugly.
By the way, Galen, we're good to go on my end, so okay. Whenever.
All right. Yeah. I'll just finish this off here. Else, error. You failed. So, we have two things that can fail here. We look up the user, and then we check if the password is incorrect. So, basically, what this will how this would currently work, like we could write this logic exactly in JavaScript, and it would say, "Yep, this looks great." And what would actually happen is, like, if this does not go to plan, either we cannot find the user in the database because maybe they just have never signed up, or we made a mistake. Our code is actually broken somewhere else, like the insert function is broken. Then this is going to panic. And if this fails, then this will also panic. However, what we can do instead is we can say that instead we can use either to model this better. So we have either error or authcred. So error will just also be a type of string. And we can instead say, instead of panicking with this error, and this is like a real Haskell function, you can use this if you for some reason want to panic, but you don't ever want to. You can then say else left you failed, and this will be a way of modeling to the rest of your code that there has been an error, and I'm giving you the error message. Please pass this along. And then I'll say write user. So write, things went according to plan and went great. And the same thing would happen here, is that we then need to say case user of left error, and we just probably want to say like left error, like continue on with that, or it is the correct user, and we want to continue on with our logic. So this is semi-valid code here that I've written, and this is just a simple demonstration of how using either as a key concept for error handling allows us to write safer programs. And so with Kyle being ready, I'll stop sharing there.
Cool. Thank you. Yeah, that I use either a lot in this code, so that'll help. Okay, so it was just a local user issue. So if you're ever running like a like an organization and you want really quick onboarding for people at your company, I suggest using Nix OS TM. This error wouldn't have happened if I was using Nix all the way to my operating system, but right now I'm just using Nix within a container or within a shell. So user errors or permission errors can still happen if it's requiring access to my operating system. So if I run Nix shell, you see I've got Postgres open here. We do have this DB serialization server, but there's no database for us. We just had it actually create the database for us, which is great. So if I refresh this, we should see our DB serialization database now. In the schema here, in tables, if anyone hasn't seen Postgres before, that's okay. We can maybe do like a full lesson on databases and how they work. But effectively what this is, we've got a schema, which is basically like a group of data. We're just using the public schema. And then within that, we've got tables. What you'll mostly use, like there's a lot here, but what you'll mostly use are tables and views. We're just going to be using tables today. And so this is like you can think of each table as like an Excel spreadsheet, right? It's a columns and rows of data. So great, the database is created. What do we do next? So the next thing that we want to do is we want to set up our Haskell environment. I'm going to use Cabal to do that. You can run like Cabal init to generate this file. Like you don't have to type this file every time, but because I've already done it, and in order to save time, I'm going to just copy this file in here and explain it. So this is, if you might have worked with like a package.yaml file in JavaScript or like a requirements.txt in Python. There's various other types of package definitions. This is essentially the same thing. We're just defining like what is what are we actually creating here? We're creating an executable called DB serialization. We're going to specify what our main function is, where to find those functions, the current version of Haskell that we're using, as well as all the build dependencies. Now, quickly we'll go through this, but basically these are just all of the different all of the different packages that we're using throughout the code. Uh, you don't have to even like remember this up front. The compiler will tell you like, hey, I don't know where to find this. Maybe it's from text or maybe it's from ASON. But basically this lets us do basic text functions. Servant is a server application. So this will serve it with mixed with way and warp. This is going to be creating an HTTP server. We're not good. This is beyond the scope of today, but it'll help us in what we're doing. And then the main libraries that we're going to be focusing on are these ones here. So ASON allows us to work with JSON JavaScript object notation, which is just like a way to format data, and that works with Servant. And then we've got persistent PostgreSQL, and persistent template. So these are what we're going to be really focusing on. This is allowing us to model the database. And so I will just run this. This is going to fail because those don't exist yet. I'm just going to remove them for now. If I open the terminal. There. And now I will run cabal run. So cabal run is actually going to fail now that I think about it, because I need to create this app folder and give it a main.
Just saying, it wouldn't make sense for the purpose of this demo, but there is like if you guys are starting a project, you can just do like cabal init. There's also like cabal. I think this is now default, but you can do cabal init dash dash interactive, and it will like walk you through like, you know, do you want to add this? And like there's even an option too to add like a ton of comments in the cabal file, like explaining like what everything is.
Yep.
You know, so yeah.
So I just added that file there now, and we're going to have it run our main. It says hello Haskell. Fantastic. Okay. So now let's actually define our the domain model. So with anything, we're always starting at the domain layer, meaning the actual types that our code is going to use. We like to something called domain-driven design is really popular in functional programming. And we can go into more of what that is, but it's really about just like what Galen was showing in the last lesson about like breaking your types down into the smallest possible pieces. That's kind of all that domain-driven design really is. It's just like modeling the real world in your code, doing that first, and then having everything else kind of build onto that. So first, I'll start with a shop. So I'm going to copy these all in. And just for sake of time, if there's any like of these that if there's anything I'm doing that doesn't make sense, feel free. But I'm just going to be copying in all the imports so that I'm not iterating through the compiler, having it tell me what I'm missing.
Effectively, all you're importing there is just the ability to do JSON manipulation.
Yeah. Yeah. Okay, and so I guess first I'll model the shop.
And then type classes, I believe, is your own module.
Yep. Exactly.
And shop error is another great example of like what Kyle was talking about with domain-driven design, because it's like you know, Kyle, you'll probably get into this already, but like you know, what can go wrong, and just like you know, you're just thinking about what can go wrong with this logic, and then creating an error type so that you can, it's much easier to have this than just a string, which can be anything.
Yeah, these can be pattern matched on. There's a bunch of benefits of doing it like this. This is called a sum type or a discriminated union in other languages. It's basically just saying shop error can be shop number wrong length, or it can be shop number not numeric with a text, or it can be location code wrong length, or right. So it's this type can be any of these. And so what we're doing is we're just creating a object for shop, giving it a shop number, a shop location, and a shop name. Now you'll notice I'm not doing like shop number string or shop location code string. We can do this, but then we don't really have any way of knowing whether this string is valid or not. And so what we like to do, this is again going into domain-driven design. Domain-driven design encourages us to break it down to the smallest level, right? So a shop number does have rules. Like we have rules on our shop number. And so first thing I'll do is create the type for shop number. And I'll put it down here. Right, so we've got a new type shop number, which is a text. And this basically just allows us to work with it as a JSON type. And generic allows us to pass it. This is required for persistent. But again, all of like the compiler is going to tell us about all of these things. Like if you forget this, the compiler will tell you. So it looks like I might just be magically adding derivations here, but no, the compiler will tell us. And I can show some of that, but I just want to get this all in the way here. So then we've got our data location type, similar to the shop error. I'm just modeling all of the locations that it can be. So these are all the provinces in Canada. It's a Canadian application. And then we're going to model the shop name, which is again just a text. So we've got our shop number, location code, and shop name. And then what we're going to do is we're going to use a concept called smart constructors. So basically, like any of these types, you could create them just by going like this, shop name. You could say that the shop name is dog, for example, right? This is okay, but like, what if we want to validate shop name? Then we have to write a separate function that makes sure that dog is actually a valid shop name. And so what we like to do is use this concept of smart constructors, which basically all it means is that we're adding some layer of validation before we actually create the type. And so this smart constructor is actually for shop number. So smart constructors start with MK before it. That's just like a language idiom. And what we're going to do is we're going to take a text and we're going to return either a shop error, that shop error that we created before, or a shop number. Okay. And so for make shop number, we just take in that text parameter here as num. And we're going to use, this is called a guard. So if you don't see an equal sign here and you just see it go right into a pipe, this is what's called guard syntax, G-U-A-R-D. And it basically allows us to one by one specify the types of, one by one specify like different rules that we want to apply and then what we should do. So you're actually like using num here. So what we can do is we can say, okay, is the length, using t length, is the length of the number not equal to 4? If it is, then it's shop number wrong length. So this is the shop number wrong length error from above, right here. Otherwise, we can check if this, so LM just allows us to like check if an element, this is basically like the Boolean is equals. So we're saying if this, but it's for more than Booleans. It's basically like just checking if this is equal. So we're F mapping is number over each character. So fmap, this maybe is a bit too much for this lesson, but this is functor map. So it's like a string is a list of characters. And so with the list of characters, the character would be a functor of the number. And so you can map over that, basically just discard the list or discard the fact that it's a string or that it's yeah, just count the fact that it's a list and just operate directly on the number itself.
It's kind of like map dot or like for each in JavaScript.
Yes, yeah, yeah.
Right.
Although you can use fmap for more than just enumerables, right?
Right.
So like if we were like in this case, this is pretty much doing the same thing that for each would do, except it's well, for each is relatively safe. But yeah, like fmap can be used for like everything, and I'll show
Yeah.
you or anything that's a functor, which we can get into later.
Yeah.
Um,
And I will stress that point that it is safe. Like it's funny because like when you start getting into those kind of functions, like you know, list.find or like in JavaScript, like list.find, list.for each or whatever. It's very. I find that's like almost the easiest way to like have a like a runtime error in
mhm.
JavaScript because it just doesn't model it very well. Like it kind of like you know.
It still allows you to do indexing, so you can
Right.
still get an index out of bounds error. Whereas this doesn't. There's no index. It's just for each thing that's in this list, it will unpack it. So this is just unpacking this num as text, checking if it's a number, and then returning a bool. And so LM will say okay, if any of these, like this is going to return me now, and instead of having a list of characters, it's going to return me a list of booleans. And so LM will just run over that list of booleans, check if any of them are false. If that's true, then we're going to return our shop number, not numeric. So this is just saying, hey, I found something in the shop number that wasn't a number. And then otherwise, if I forget this otherwise case, and I might actually, in case of time, like I want to get this going. So if you were to like, you'll have time to experiment with this code after. If you were to remove this, it would tell you that it's required, right? And so you always have to handle, like in Haskell, you always have to handle the true and the false. You always have to handle the if and the else, right? A lot of languages allow you to leave out the else. Haskell does not allow you to leave out the else. And that's very important. And then you might be saying, oh, well, you're just going to have else statements all over the place. That's why we have constructs like either and all these different monad, like that's where monads come in and basically allow us to just make it so that like we don't have to write that everywhere. All of those side effects are just going to be passed down to their lower context. So I will move forward and define the other smart constructors. This one's for location code. It's just checking if the location code is two numbers long, and if it exists within maybe from text. Yeah, so from text LC, we'll return it. I'll have to implement that after. But this is using a maybe, so it could still be false, right? The invalid location code will tell us that it doesn't belong to this list here.
Kyle, just for a quick heads up, just a time check that it's 11.
Yep.
Just to keep you on track for timing and to allow for some questions after if there are.
Yep. It's good. That should take me. I'm just gonna power through this. There were a little bit of issues at the start there, so. So then we've got another one, make shop name, does the exact same kind of thing, and then make shop. So this we won't explain too much in terms of time, but this is basically just applying all of these different functors to the shop type. So we're creating our shop here.
And I'll explain this quickly because I feel like this can be complicated to explain, but we do want to explain quickly. If you look at, could you pull up? So notice that like there's like three like pieces here. And if we go back to shop, we'll notice that there's also three pieces.
Yeah.
So yeah, this is basically like so ultimately, like, why we need this like sort of syntax or it's not actually syntax. These are like functions to help us out here, but the dollar sign and the asterisk things are because make shop number, make location code, and make shop name are um, all returning an either a shop error or the thing, and so we want to then combine from all of those possible failures. So
Yeah.
what this will do is, like, let's say this fails at make shop number, then the shop error will be the same from same thing that was thrown by shop number, um,
Yeah,
and it
exactly. This is what we were talking about, where you don't have to handle all of these cases everywhere. We're just mapping over them. We don't care that we don't basically when you learn more about this, it'll make more sense. But we're basically saying we don't care about the either in this case. We just want to use the we're going to return either a shop error or a shop, and so shop is expecting just this shop. So if all of these succeed, or sorry, yeah, it's just referring the shop name location code. If all of these succeed, then shop will be created. If any of these fail, it'll return whichever shop error came from either of these, and it'll return that as the error. So it's really, really nifty.
And too, so like just a note on these like sessions, like um because this might be the case here, if you're like feeling like any bit like overwhelmed by I don't know, maybe the syntax here, like this is where like the lessons really do come in handy. The like the way that you should use the individual lessons and then these sort of video lessons, um these video lessons should be like exposure to like how do you actually do Haskell or whatever. What's a concrete example you can kind of look back on and say like if I want to make a database, how do I do that in Haskell? Whereas the individual lessons will teach you stuff like how does either actually work. Like if you want to get into that, and how does these functions here actually work. And so if you really are detail oriented, and want to know absolutely everything that's going on here, um, then like those lessons will really help you out.
Yep.
So and we're
Yeah,
here to
exactly.
help. So if there's any questions, like even like right now, like fair, like we really encourage them to be asked. I think it also makes the session more fun when there's more questions. Um,
Yep.
you know,
So I'm going to just do this, copy this automatically. For product, we're doing exactly the same thing here. It's just we're modeling a product instead of a shop. So I'm not gonna go through each line and explain this, although I'll just show the product type. We've got a serial number and a product name. So the next thing, I'm just gonna copy this type class in here. This is not super necessary for you to understand yet, but this just allows us to get the text out of any element.
sorry, I don't know if this is on purpose. I'm not seeing any typing, or I'm not sure if it's on a different screen. Maybe
What do you mean?
like I just see like make shop still. I saw you were typing some classes.
Do you see type classes right now?
I just see like make
I see
location
type
code. Wait, what? Oh,
Yeah, I think your screen's frozen.
okay.
Maybe
There might
I'll
be,
try to. Yeah,
because
sorry.
I'm seeing type classes dot, like your type classes file.
Never mind.
Yeah.
Just ignore me then.
Well, I'll just because someone else might have that issue too. Let me
That's
just
fair.
reshare my screen.
Anybody else? Kelvin, Legita, Sarah? Can you guys see, or one second.
There should be, if it's fixed for Galen. It should.
Yeah, I can see his type classes.
You can see type
Paul?
classes?
Yeah,
Okay.
I can.
Okay, good. All right.
Perfect.
So that is just a detail. We won't focus on that right now.
I'm gonna drop off and then come back on. That's what I'll do. I'm not sure
Oh,
what
okay.
was happening
No,
to
it's
me.
not working still.
Yeah,
Sure, sounds good.
it's whatever. I'll figure it out.
Yeah, it's a local issue. Okay.
Recording
These
is
will probably
on.
get removed from Haskell at some point. Basically, what this is like it allows people to add features onto the language, and so the team behind the Haskell compiler has already said like many of these are just going to be added into the next version of Haskell, and so they basically just allow us to write code in certain ways. Don't focus on them too much. We'll usually be providing like you can put all of these into a Cabal file and then you're fine. You don't need to worry about it. I just put them here just to show that they exist. So to create our database, it's actually very easy. It's probably one of the easiest. So there, database is created. And so basically one of the things that Haskell's really good at is creating like domain specific languages. So like languages within the language. This can be slightly confusing if you don't know that you're working with one, but when you are working with it, it's very, very powerful. So this share type comes from persistent. And basically what we're doing is we're just creating a persistent database with the default SQL settings. And then we're running migration and we're just migrating everything in our database. We won't get into database migration today, although you will see what it does. And then persist lowercase, this is literally just telling persistent to turn all of these types into lowercase, or like all of these tables into like lowercase styling. So what we're doing here is we're actually we're doing two things. Not only are we defining the table, but we're also creating a type that perfectly maps to that table. So product registry has, a serial number and a product name, and then this U before the product registry here, this means that this is a unique key. So you might have heard like primary keys, foreign keys, unique keys. This is creating a unique key called product registry, and it's attaching it to serial number. Okay. Similarly, we're creating a shop registry. This has a shop number, shop location code, and shop name, and then a uniqueness constraint on shop registry, which is unique on both shop number and shop location code. So like this literally creates the database for us. There's nothing else really that we need. I mean, we need to execute this, but this does everything, which is very, very cool.
I'll add some points of verbosity here. So
Yeah.
I believe that you're using you must be using template Haskell.
Template Haskell, yeah.
Yeah. So this example like is not super familiar to me, by the way, if you're watching. But yeah, so template Haskell is basically just a meta programming of Haskell. Like you can like how I'm able to kind of figure this out is that like Kyle, you're saying that it creates the data type for you. So basically, what this system is saying like work with our domain specific language. There's probably some documentation you've read somewhere on how to do that, and
Yep.
then it's going to create these data types for you. And I think you even like like how we had shop or shop code, I think was a data type. How you saw that in in functions. You can do the exact same thing. You can write functions which use these types.
Yeah. Yeah, and so that's what we're actually going to do right now. I'll show you. So I've just created a run DB function. Again, this is just in their documentation. There's pretty much one way to do it. And we're just basically saying, okay, with this string connection, give me the back end and then run reader T on this. So this is, I won't go into the reader monad right now, but basically this is just running this database. And then there's a migrate DB function as well. And so this is like, we're working with a library. Like you could go into persistent and like understand exactly what it's doing, But in this case, like we don't need to. We just need to set up our database and we need to run it.
And actually, I can see too. Just I think the quickest way of explaining what that is doing, the run DB, how it might look complicated because it's using like a higher order function and reader T or whatever. But
Mhm.
I can say that what that's doing is it's really just passing a config from Postgres to your functions. Um, so
Yeah.
like anywhere that you would need to use like sort of Postgres config, you were able to do that effectively.
Yep. Yeah, and the action that we're passing to RunDB is the migration action.
Makes sense. So it probably has like some config about where the database is located, like your connection string, and then runs the
Yep.
yeah.
Yeah, exactly.
Cool.
And so I've just created two types or two functions here. These functions take in a product and then return an SQL persist T, which is just a monad transformer for SQL persist. So this has everything that it needs inside of it to do persistent SQL queries. So it'll handle all the side effects that it needs. Maybe it stores onto some state, it interacts with the Postgres database, which is probably a custom monad that they've created for persistent. Um, and then we're going to be returning a maybe insert error. So it'll either return us no error or an error.
You use a new term that I think we should elaborate on. Monad transformer. What does that mean? It sounds like complicated and like cool, maybe like
Yep.
transformers. But but
Yeah, you can go ahead, Galen.
so,
But just
so
keep it short.
yeah, totally. So a monad transformer, what like builds off this core idea of monads. And so I'll start with what a monad is. A monad, like when we talk about it in this sense, it really just allows you to do some sort of effect. So either, for example, is a monad, and either has the effect, which you saw how it works already. There's nothing more complicated or behind the scenes about it. Um, it just allows us to model failure. Um, so let's say we want to model failure, but we also want to have a monad that does SQL stuff. So we can stack the two on top of each other, um,
Yeah,
and yeah, and we don't
that'll
necessarily
make
need
a lot more sense in the future, right? Now,
yeah
it's a little bit confusing. Like, why would you want to stack them on top of each other? Basically, you want to be able to. We're specifying layers of an onion by doing this, right? It's like this thing should handle errors, but it should also communicate with the database. It should also store some state.
yeah.
And the reason why we're doing that, you might think of it kind of like inheritance, but inheritance doesn't do a lot of the same benefits. Like this actually binds the context and allows us to, again, use those same monad functions, those same applicative functions to sequence these operations together in a safe way. So it's like inheritance kind of, but a lot more powerful because it first of all everything is like you can pattern match on everything. Everything is constrained to the same type. Whereas with interfaces, oftentimes they're scattered throughout the data, throughout your code base. They don't really like. There's no guarantee that an abstraction of an interface will also work with the other abstraction. Like if you have two abstractions of one interface, you don't have any guarantee that those two abstractions will be able to communicate with each other. Whereas in this case, it kind of handles a lot of that complexity for us. And so you could have the either effect be applied to, the state monad, for example.
Even to bring it back to like a JavaScript example, try catch is technically a monad. You guys are probably like you can get very complicated in the explanation of monads or
Hmm.
whatever. I actually like I had more experience for a while with Haskell than JavaScript, and the way I thought of monads is that all they do is allow you to ignore them. Like
Yeah, yeah,
either is like so the either monad like that term or whatever, either is what's doing stuff for you. The either data type allows you to model failure. Monad is just it's a class And we haven't talked about type classes at all and how they work in Haskell. But it's just basically an interface to say, I don't care about either. If it, like, so let's say we have like the simplest example is we have two eithers with an integer in them. So we did some validation that this integer is not zero. So we have either fail, what the failure says it is zero, or a integer. And so now we want to add those two together. We can use monad rules to add the two together so that our inputs are an either error int and an either error int, and our output is an either error int. And all we've done is we've effectively just added 2 plus 4, or whatever the heck the integers are.
Yeah, you can specify what the internal types, what logic should be applied to the internal types without focusing on the external. Is kind of a good way of thinking.
Yeah.
This is a container. It's like an onion, right? And we want to go directly into the third layer of the onion without ripping off the second and the third. Or technically, we're ripping them off, but then we're putting them back.
Yeah.
Okay, so with that, I've decided to just go ahead and write down the API code here, because this is not the focus of this course, but I will just show you it because the code will be available and you might be wondering. So what we're doing here is just creating HTTP routes. This is using the servant package. And then we're just creating a server which runs these two functions, create product and create shop. And these are literally just calling our database functions. So we get a response, we pattern match on that response. In the case that it's a value, we show it. In the case that it's not, or sorry, just as an error. So in the case that it's an error, we show it. In the case that there's no error, we just say success. So that's very simple. The application starts it up. And then here is where we're actually doing we're actually starting this code. So I will just run this because I feel like we've talked enough about it. The one thing I just want to note is that if you see here with this insert unique function, product registry, where we didn't create a product registry type anywhere, right? But we did right here. So this is actually creating the type that we can use in our code, which is very neat. So this here models the database. So now if I run cabal run and cross my fingers, okay, there's some error, variable not in scope, variable not in scope. Okay, why is that? Oh, yeah, okay, my bad, I did not import them. So I'll just import these. Did I forget type class? Did I try? What? I might not have copied over all of the.
Oh, you probably.
No, I know what I need to do. Yeah, it's just. Oh, yeah, I didn't. That's fine. I didn't copy over the language features. So like you see here, it'll actually just tell me, oh, you're doing something that requires a language feature. I think for product I did I? Yes, okay. Not gonna worry about these. They're just telling me that certain things are not used. And so if we looked before, like if we remember, we have no tables, right? And so this, look at that. It actually just created a bunch of tables in our database and it started up a server on port 8081. So if we come into here, we refresh our tables, we now see we have our product registry and shop registry. So if I open these, data, all rows. You can see here that it has the types that we created. It creates its own ID. And then we've got our shop number, shop location code, and shop name. And so this, like, for example, in Postgres, this uses character varying. But if we were to use a different type of database, it would create whatever so it binds the database type to the actual type that you specify in the code, which is uh, pretty powerful. If you've done any work with databases, you often have to specify this yourself, and sometimes there can be issues that come with that. And so, yeah, both of these are now tables in the database with the right fields. So what can we do with that? Well, now we can use the API here to actually interact with the database. So I've created these two routes, API product. This basically just means a slash. It does a little bit more than that, but it's a slash. So this is going to be API slash product slash create. It's going to take our product as a JSON object, and it's going to give us JSON text back. And so, like we said
Sorry.
here, it just calls create product and create shop. So I'll show that while Galen's talking.
Yeah, well, I'm even just curious, like with seeing that for the first time, obviously there's it looks like there's like new syntax. There's actually not any like new syntax there.
Mm-hmm.
So
Good point. Yeah.
yeah, but I'm curious, like, can you kind of like get if you're familiar with APIs, like, can you read that at a high level and think like, oh, okay, like I kind of roughly get what this is doing. Maybe like you feel uncertain about
Important.
it,
Yeah.
but um, like because I mean, of course, I can. I'm familiar with this servant API library. But I'm curious. Like I think one of the cool things about Haskell is that it is so flexible that it allows the library creator to model things in such an intuitive way. So like I can look at this, and I'm really curious about that answer. Like if you guys want to give an answer in the chat, if not, no worries, no pressure. But to like, can you read this and get an intuitive sense of what's happening here?
Yeah, and I want to that's a great question. Please do answer if you can. But the one thing that Galen said is actually really important. There's actually very little syntax in Haskell. A lot of people say there's a lot of syntax in Haskell because they see operators. They see these things, right? They see, oh, there's this colon. How am I ever going to remember all of these operators? Like like there's so many different operators that we're using. They're not operators, they're functions. And so each of the, like, I won't go into it right now, but like each of these can be, so you can write it in two ways. I could go API like this and then shop, or I could do this, right? And so this is just a function that gets applied to this and then this. And so this gets into what's called infixing. And so any function, like actually any function, like even this create product, if I have any function can be either prefix or infix, meaning it can go before and have all the arguments here, or it can go in between two arguments and take the first argument from the left. This we'll explain this more in the theory documentation, but just understand that like anytime you see these, they're not like specific language thing. Like this belongs to the servant package. It's a function that they created, and they just made an operator. They just made the operator infixable. So you're able to put it inside of two parameters as opposed to having to define it like this all the time. But it's exactly the same thing. It's just a function, and you can look it up and you can understand what that function does. So don't be like, don't worry like that you have to remember all of these operators. No, like they're just functions that you can search in Google.
And I'll add to so I think servant is one of the coolest packages in all of Haskell, in my
Yeah.
opinion.
Hmm.
Um, you know, if like the complexity of like how the library is built, like the mind of the creator who made servant must be an absolute genius. And it's like it's really hard like when you like try to dig deep into it to like understand like how did he do this, because like you can really use a lot of powerful features in Haskell. But that said, you also don't need to know that at all. You can look at their servant documentation, and you could literally like learn about the two operators, the colon, yeah, the one that the one at the start of line 25, and then um, the other one, the like
That's not it.
the colon angle bracket and the colon angle bracket angle bracket bar. Let me just type in the chat. This one
Okay.
here, um, and this function. You can literally learn about these two functions, and you'd be just about good to go with Haskell. Or sorry, with servant. Um,
Yep.
And you don't even have to like look at this Google documentation necessarily, because there's like a tutorial on like how to use it or whatever. The key point is like Haskell, like one of the sneaky um, points about Haskell is that like I guarantee you, and not even guarantee you, I know that this is true at this point, that Haskell has better libraries than any other language. Like dead stop.
It's the best for creating libraries. Like
Yes.
we can use it, but traditionally Haskell has been a library language. But now the runtimes are getting really, really strong. So it's like, why not use the libraries in the actual runtime itself as well?
Right.
So yeah, so that without like just time check, without getting too deep into it, this really just gets the point across that like they're just specifying this as an infix R4. So this means we'll get into infix, but basically just means it can be added in between two types.
The only last point I want to make is that like you have a library creator who's done something amazing, and then what they've done is they've exposed a very small domain driven design to you, that all you need to do is understand that,
Hmm.
and then you can build something that like is absolutely perfect. And even if like you along the way are struggling to do that, um, once you know the basics of Haskell, you can kind of like almost play compiler chess, and um, you know you'll end up with this beautiful API that works perfectly, kind of thing.
Yep. And the big difference between this and JavaScript libraries is you can trust the library developers. When you're using a JavaScript library, you cannot trust the developer. There's no like, what if they forget a catch? What if they forget an else statement? You know, this happens all the time, and you're always seeing packages get patched and everything like that. No, this will work exactly how you expect it because they're using Haskell as well. And so with that, I want to show how the application actually works, and then have some time for questions. There is a quick second part to this, but depending on time, we'll see. So what I'm going to do is this is Postman. This is just simulating a network request. And so I'm just going to make a request to this API/shop/create. It's going to expect a JSON object, which if you remember in here, we created an instance of to JSON and from JSON, and we specified this is how we want the to look. So we want it to be shop number, shop location code, shop name with lowercase or with a camel case. And so there we go. And if I hit send, it says success. And then you can see down here that it actually, first it did a select to see if it was unique, and then it inserted. So we didn't tell it to select to check if it's unique and then insert. It just did that because we specified that we want it to be unique. So actually, no, it was this insert unique. So insert unique function is what handles that for us. And it's able to do that because of the unique type. And so if I check the database again, it was the shop. We can now see our shop here, right? I can try to add it again, and we will get that shop error here. ON, shop number 1200 has already been stored. So if I want to add another shop, let's add this one for Quebec City. Shop QC. we can add that as well. Similarly with a product, this is an example. So the second part of this example is actually attaching the thing, but we might not have time for that. Give me a second here. Okay, so we can now also create products with a serial number and a test product name. If I try to add a serial number with the same serial number, it's already been stored. If I try to add a serial number that is not 8 characters, the serial number you provided is not valid.
Recording has stopped.
Oh, Lauren dropped, I think.
Oh.
Temporarily, I think, maybe. That's okay.
Oh, can
You
you
still
hear
have
me?
OBS. You still have OBS, right? Kayla?
Yeah,
Wait,
I still,
you
I
guys,
still have OBS, yeah.
Okay, good. Sounds good.
I can hear you, Lauren.
it just stopped the recording for me for some reason.
And so there we create another.
Okay, well, that's all right. I have OBS.
Recording is on.
We can stitch them together.
Yeah, no problem.
And so there we go. We've got 2 products now with 2 different serial numbers. And so that's really like you can keep growing on this, get more complicated, right? We can have foreign key relationships between different tables, etc. But I think that's really all we need to show at the moment. And so we've got 30 minutes. If anyone has questions, we'd love to, or even just comments, what did you think about that? We'd love to hear them.
Okay, so 2 things, Kyle. There's 2 questions from Sarah in the chat itself, so maybe take a
Okay.
look at those.
Oh, yeah.
First one is, can we run PG admin for SQL through Haskell? If you can see that, and then maybe just take a look at those. And then in the meantime, while Kyle is taking a look at those guys, Sarah, great questions. I love that you're engaging. It's so nice to see you get involved. Kelvin and Olajita, of course, this is your time to ask questions, so please do. Like I said before, our groups won't be so small for long, so this is your time to pick their brains, even if it's not about today's content. Like if you're still just digesting what you learned today and it's about something else, now is the time. So please feel free and give us feedback on the content. Like, was it super confusing? There was nothing that you got. Let us know how you feel about that, because we're here to build for you guys. So Kyle, maybe you can get started with Sarah's questions, and then Kelvin and Olajita, if you have any questions, drop it below.
Sure. Yeah, I can. I'll answer Sarah's first question. So, can we run PG admin for SQL through Haskell? So this right here is PG admin. You can't run it through Haskell, but you can run it through Nix. Right now, I'm actually just running it on Linux because so Nix OS is fantastic because it'll let you just like set it up automatically. But for me, all I did was I just downloaded it from the Snap store. So like Snap is like the app store for Linux. That's going too high. Where did I do it? Ignore these errors. Yeah, so like I just downloaded it from the Snap store and just ran it here. So like as long as PG admin is running on your like it's running on the same machine that the server is running, it'll have no problem connecting to the database. In order to do that, I just came into servers, registered a new server, gave it a name, and then like here is where you can add the credentials from this in database. So we have this connection string here. So I literally just added like host is localhost. The DB name will be DB serialization. That'll be once it gets in. User, I just put in my username here, right? And the password, a very secure password of password123, right? And then that just allowed me to create this here. And then that lists the DB serialization database once I create it. So you can do everything inside of PG admin. You can even write your own queries in here. But yeah, we're also interacting with it from the database. And
Actually,
then
oh,
how to
sorry.
apply Haskell to data analysis.
The last thing I was going to say too, by the way, for the first question is just like when we get to Obelisk, we could also. It's not really the same question, but like it is a lot easier to set up like database administration through Obelisk. Or like there's a lot less like manual setup that you have to do for that specific library, but it wouldn't make sense
Yeah,
to
there's
show here.
framework. There are frameworks, right? But
Yeah.
we didn't want to
Totally.
show you the how it works before we just show you the magic.
Right.
Um,
Mind
for
if I?
data analysis, yeah, do you want to take that one, Galen? Because I know you've done a lot of data analysis with Haskell.
Yeah. So we although we've very much slowed down on our efforts and kind of shifted direction with our data analysis, um, we have done a lot of like natural language processing. So as well as like even in a lot of my own projects, I've done there was a time where I did a lot of like Amazon projects. So automatically analyzing people's storefronts on Amazon, determining what products they should buy more of, etc. And so like the two, I guess, like workhorses of that is like A, getting data, and B, analyzing data. Um, I've actually created my own library for web scraping and Haskell to very precisely scrape data in a particular but dynamic way. And so, like, that's how I would use it for getting data. On the other hand, which is probably more aligned with your question, like data analysis, there's quite a few I've kind of also just built my own as well, but that's more for fun. Like there's like Cassava is like a CSV library. There's like text.csv. And I find it a lot easier to model complex relationships because like otherwise, like if you're doing it in like Python, for example, you're just you're looking at it as like rows and columns, and that's kind of like the extent to your data types. Um, Whereas there's probably a more complicated relationship in there that you can derive through certain checks. So maybe that'd be a great that'd be probably a great session to go through is data analysis in Haskell. I think that deserves its own session. Now I think about it. Um, but yeah, lots of libraries to do like CSV analysis and that sort of thing.
I'm pretty sure there's even like TensorFlow packages and stuff like pretty much okay. Like name a package
Oh,
in
Matplotlib.
Matplot. Yeah, so we go to hackage.com. Like I would challenge you. Like I would say like come to hackage.com and just look through the kinds of packages that exist because they all exist and they're all very strictly typed. So like you're not going to be dealing with like weird errors that come out of nowhere. Like I would argue that like if you go matplotlib, boom, matplotlib. So people have actually modeled matplotlib in Haskell, right? And so you can see here it's matplotlib. Where does it say? A Python plotting library, right? And so this is what's called a DSL on top of Python. So it's going to create Python and it's going to use it, but you're not going to know, or I believe this would create Python, but it might not even, it might just like re-implement everything. Oh yeah, it does. So
It does,
here,
yeah. Well,
so go ahead.
sorry, it doesn't necessarily like it kind of creates Python code on the fly and runs it through the matplotlib or like Python executable.
Yeah,
So yeah,
but
there
it
is
does
like
that behind the scenes. Yeah.
yeah
So and we go TensorFlow, boom, TensorFlow. So it's like though I think the best way to explain like Haskell can run any code within it. Like what I'm just out of curiosity. Language C#. I can write C# in Haskell if I wanted to.
yeah.
I don't know why you would want to, but you can. Python. You can write Python in Haskell, right? Like the best way to explain Python or Haskell is like it's a massive like it's like a compression function where it's like it's really what it's called is, I'll explain it here, EDSL. Embedded domain specific language. So basically it can take any language that you want and it creates an abstraction layer on top of it. It's even got, like, I'm just kind of whipping through stuff so you can look at it on your own, but even like the foreign,
Want to paste the link in the chat by chance? Or,
yeah, I will actually, that's a good idea. And the foreign function interface, for example. Right, and so this allows you to, like here, we're calling a C function. So there's no reason that you can't just like write a piece of C code and then call that C code from your Haskell program. So like you're not like, whereas with these other programs, you're limiting what you can do. With Haskell, it's kind of unlimited. Like it's an abstraction above all of those, right? If you think about, like, you've got assembly, right? And then you've got like imperative programming, then you've got compiled programming, then you've got imperative programming on top, or sorry, interpreted compilers on top. Then on top of that, you have EDSLs, or embedded domain specific language. And so it's like a higher abstraction than all of the other languages, if that makes sense. And Sarah, I notice you have your hand up, so feel free to.
Yeah, good evening, everyone. My name
Hello.
is Sarah, and thank you very much for the class. I mean, I'm starting to get a little bit of the idea. It was very foreign to me before, but I think I'm starting to get a picture, something
Good.
like that. So, actually, what I did before is data analysis, and I worked with SQL, Excel, and a little bit of Python. So that's like the idea that I have. So I really appreciate that Galen talked about maybe having a session for
Yeah.
using Haskell, yeah, for data analysis. I would really appreciate that. Thank you.
Yeah, we can do that soon. Yeah.
Yeah.
Well, even when we get to the like when we get like, there's really good front end libraries. Like you might have heard of React. Uh, there's a language. It's called Reflex, and like this is probably the best front end library that's ever been written. I'm not just saying that because I like Haskell. It's extremely powerful. It's extremely fast, and you can easily have these, like for example, matplotlib. Like maybe we start with data analysis a little bit, but I think it would be really powerful if we could show you like how to create graphs and how to create charts and that kind of thing, and how to display this information in like a charting environment, right? So definitely, I think that we should do that. Yeah.
Yeah, I almost wonder, like, I mean, so one other, like, where I've used matplotlib Haskell, and like, it's cool, right? Because it's like, you know, it does all the same things that like a Python, script might do, but you don't have to worry about like silly errors happening or like debugging as much. Like, of course, there's always a sense of debugging in Haskell, but like you're gonna not really like, and it's because you immediately see the errors and the compiler guides you to a correct program.
Yeah. Compiler
Um,
chess instead of debugging.
right,
We do
but
compiler chess. Yeah.
yeah,
Okay, go ahead, sir.
so all good. So yeah, I've used matplotlib Haskell to to we were looking at, like, we were doing audio analysis of like sound waves, and so I was able to create an array and then uh, pass it to matplotlib Haskell, and then it would display the data, and I could interact with it just like I would with like using Python matplotlib.
Yeah.
So yeah, I see we got a +1. So I think that's honestly definitely something we should do. Like, Lauren would like to speak.
I had a quick question for both you guys and the three of you, Kelvin, Sarah, and Olajide, because obviously there's need for. Sorry, am I paused? I don't know if my Wi-Fi is.
You're good.
Oh, okay. I was just going to say there's obviously a need to do a session on data analysis using Haskell. I wonder, do you guys think it would be useful or valuable as part of that session to do an example of like answering a question in a technical interview of how using Haskell has helped you accomplish X, Y, Z, or like doing a walkthrough of a technical question for, let's say, like a data scientist role or a data analyst role? Meaning you learn about using data analysis, but also how would you even exemplify that in an interview itself? What do you guys think? Absolutely. I'll agree.
Yeah.
Okay.
Yeah.
And Kyle and Guillaume, what do you think?
Yeah.
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 Sorry, I'm trying to not cut off you Haskell or Kyle. I almost called you Haskell. It rhymed, you know. Kyle Skull, but like yeah, no, I definitely think so because honestly, like my opinion is that like the hardest part of programming is the interview process. You know, so if you can be set up for any kind of question that way, then yeah, of course. Um,
Yeah, and I think also like a lot of what we're teaching with domain-driven design, like personally, I think that's how you should approach every problem in when you're doing an interview, right? Like the biggest thing that an interviewer wants to see is your thought process. You'll find the interviewers that they just want to see you implement a binary search. You know, it's arguable that those are the companies that you don't really want to work at. Like any good, and like I mean, you'll work there, but it's like a good interviewer, like because you got to think about it two ways, right? Like you're also they're interviewing you, but you're also interviewing them, right? So it's like you want to ask as many questions as you can about this kind of thing. You want to like the biggest thing is showcasing your thought process. Like that is probably that has gotten me a job like 10 times out of 10. It's just been like talking about how I think about problems and not necessarily just solving the problem that they ask me to solve. Um, Sometimes even not solving the problem is okay, as long as you explain like because sometimes solving a problem in 30 minutes or sometimes it's like 15 minutes that they want you to do it, like it's difficult. So like the most important thing, like obviously it's best to solve the problem. Like if you can do both, if you can both explain your thinking process and then also end up solving the problem, like you'll have a really high chance of getting that job. But more importantly than solving the problem is to explain how you're thinking, right? And so this process where we start with like modeling the shop. Okay, well, we've got a shop and it's got a shop number and the shop number, and maybe we'll do some more like complex examples, like maybe we'll do some interview questions in Haskell. That might be a good approach. But like you really want to take that step and like you can see here now, like okay, we're adding it. Okay, you ask the interviewer, okay, well, how many characters can the shop number be? Is it only numbers? Is it characters? Do we allow special characters? You're asking these questions and it's showing that you're aware of the things that need to be thought of, right? And so then you start writing your code to handle those cases, and oftentimes that alone will impress the interviewers from what I've experienced.
I also
And
think
it'll help you solve the problem a lot easier because you'll just have all the little pieces and then you'll end up just putting the pieces together. But yeah, go ahead, Galen.
sorry, I just saw a question come in.
Oh, yep. Day. Yep.
Yeah.
Olajide, also feel free to come off mute if you want to describe any further.
Put the
We'd
exact
also
measure.
love to chat with you.
Oh,
Thank you.
if so, yeah. If
Okay.
so, you must have do you have like a fork of the project?
It sounds like he just cloned, which is totally okay. Let me show. I'll just show this right now.
Yeah.
Okay. Just to clarify,
Yep.
Talking about the to-do list project.
Mhm.
So there was the first thing was to, I think, clone the project. Yeah.
Yeah.
So after writing the code and doing that, so I want to kind of understand how to push my code for review or something
Yeah.
after
Okay.
doing all that.
So quick question. It might not be. We've had this. You're the second person that may have missed this in the documentation, and I think that's our fault. So I guess maybe I'm assuming, but did you fork the project or did you just clone it?
I just cloned it.
Yeah. Okay. So that's on us. We got to make that more clear. So okay. So if you see here, so what you'll do is, where is it? Is it up here? Yeah. So on the project page here, you have two options. You can clone this here, like the typical way of just cloning a repository, right? What this does is it just clones the repository as if you were to update this repository itself, right? So if you were to create a branch and push, then those changes would come into our repository here.
Okay.
But what you can also do is you can fork your own version of the repository. So what you should do, and we'll have to make this more clear, but if you come up here um, and create a fork, then what it'll do is it'll say, okay, so now it's going to be remsuda / ATC Haskell projects, right? And so I can, I don't want to copy the main project branch only. I want to copy all the branches. And then we can create this fork. And so now I have like my own copy of this repo, and I can pull so like I can pull changes by syncing this fork. So right now it's up to date with the Haskell projects. But if I were to make a change in here, which I'll just do for sake of for now, I'll just do this. But I'll add some photos and everything. So let's say I make a change to the repo. If I come into my forks, no, oops. If I come into my forks and I click sync, you'll see it's out of date. So I can update that. And basically what this is just like it's a copy of the repository. And so what you'll do then is when you've completed your code, so for you, you might have to clone that. Like you can clone this fork and then maybe just like copy the files that if you've already worked on the project, just copy the files from the one that you cloned into here and then push to the branch. So if I'm working on to do manager, you would just get like commit and then push to this branch. And then what you'll do is create a pull request. Or wait, no, you don't actually need to make a pull request. You just want to add watchers. So where do we go? How do I do that?
And even for like this step of like watching, like if you forget this or
Or
whatever,
contributors. Sorry. Yeah, go ahead. Sorry.
you know, you can even like at this point, like if you've like pushed it to a public repository, like
Yeah.
feel free to even just send us the link
Yeah.
in the community chat, and we'll check the link, and that's like good enough.
Yeah.
This is the ideal process. It does make things easier, but like if there's a missing step or whatever, like I guess the very minimum, just like a public URL that we can go to, sort of thing.
Okay. Okay.
Yeah.
Thank you very much. I think I was a bit confused because I used the Ubuntu shell to kind of do it.
Yeah.
So
Yeah. No
I
worries.
was,
No worries at all. We can we like the feedback because then we can improve it, right? So
Right. Like this is the kind of stuff we want to make. Like it's on us to make it like very very clear and straightforward for like what to do. The Haskell learning is where the challenge is supposed to be. So yeah, this feedback really helps us to streamline that.
yep.
It was actually a very nice process for me because I was just all over YouTube and Google trying to push it from Ubuntu, and it was just interesting for me.
Yeah.
Yeah.
That's good. All right, awesome. Yeah, we look forward to seeing your submission.
Awesome. Okay.
5 minutes
So
left. Is there anything else?
yeah, I was going to ask if there's any other questions. Also, Sarah, I already spoke with you yesterday, but Olajide and Kelvin, I'm also setting up specific like one-on-one calls with our users who are showing up to these sessions to get a more in-depth understanding of what you guys are looking for. So Olajide, Kelvin, I'll message you to set up those calls. Hopefully you guys can still hear me because I'm super frozen on my side.
Yeah, we can hear you. Yeah.
Okay, awesome. And I had something else, but I totally forgot. So if there's anything else that you guys have questions for, any comments or feedback or anything like that, again, it's super, super helpful for you guys to engage. So I also am so happy that you guys asked questions. You showed up today. It was awesome to have you. Kelvin, floor is yours, my friend.
I was just gonna say, it's a nice lesson. At least I have done some coding before. I have interacted with Postgres, and so I do have a gist of what is going on. Although I have to go back and kind of understand more matters the syntax and maybe doing the functions and all that, because I feel like it's too much at the moment. But at least I get what's going on.
Mhm.
Yeah, I've already forked the assignments and all that and the projects that we are required to do. I would encourage you to do more of this, because when you do this in a live session, it feels much more relaxing and easier than just a online process.
Sorry, the sound
But it
effects.
is a nice session.
Sorry, I love these reactions. I didn't know that was going to be the response of it. Sorry to cut you off there, Kelvin.
No, yeah, we appreciate the
Yeah,
feedback, and
it's alright.
it's why we wanted to do these live sessions, is because we're going to continue doing this. We're going to grow the community and grow
Yep.
you guys
But
are very early. So
I,
yeah, go ahead, Calvin.
I recommend we do it in small chunks, because right now we have created a whole application.
Yeah,
If you know what I mean.
that's fair.
Yep.
We've kind of created a whole thing. So if you broke it into small sections that would maybe probably build on top of in each lesson, it would be much more easier than doing everything, because most of the code was just copy paste. So you're like, okay, I know what is happening, but I did not clearly understand what's going on.
Yeah.
So if we say today we're doing the database and probably handle one function until we get what's going on, it's much more easier because it's a new language and some of us have not been,
Yeah.
you
Yeah,
know.
that's totally fair. Yeah, the intention was to kind of just show you like what can, I guess it was intended to be that way, but I think you're right that we need to like next session what we'll do is like actually dive into the functions themselves. We just wanted to kind of show like this is really all you have to do to create like a full application. Um, and the idea is to kind of, how do they say it, like throw you into the deep end, right? It's like this is like what you need to learn, and now we're going to take a step back. So we're going to take a step back and we're going to say, okay, of all of these things, like what are the different features that you'd like to understand? And so we're going to give this code, I'm going to upload it to a repository. And it would be great, if you could like point out certain things that you don't understand. Like that would help us extremely. We're going to be handing out like a survey asking like what you want to learn. Right now it's a little hard because you don't like know you don't know the right questions to ask, which is like that's the case when you're learning anything new. You don't know, not only do you not know the thing, you don't know what questions that you need to ask to learn the thing, right? And so we're trying to expose that to you, but we're open to suggestions.
I,
Yeah.
I think even too, like one way we could potentially like implement the suggestion, because I do think like like I think so much of what we're doing is like very much an experiment of like how to teach. Um, so like because I feel like in the past we've like tried to teach where it's like okay, like we're gonna start from square one and like learn like one thing at a time and continue to build. I think what's hard with that is that you'll get people who like they don't see like the what you can do with it fast enough. So I think that's kind of why we did a session like this. But I do think that like what we could do from here is take this session um, and break it down. Like the next session is just about create product. Like the singular like one thing. All we do is break down what the heck is happening from line 33 to line 38. Yeah, in full.
Yeah.
Um,
Yeah.
here's for
LG Day, you had a question, but you put your hand down. Do you still have a question or a comment
It,
or anything?
it was just a comment
Yeah.
about something. So first can we get the link to the YouTube channel? And I also think it would be nice to have like short videos sometimes, maybe once in a week, where we can just go as a reference to understand like certain things. For
Short
example,
short videos is
yeah,
what you're saying.
yeah,
Yeah.
short videos.
yeah.
For example,
I will
because
say
I was yeah.
yeah. No, I
Well,
sorry, my bad.
yeah, sorry. One thing. Yeah, sorry. I was a bit confused on the API part, so I was trying to understand. The whole
Hmm.
deal.
Makes sense. Yeah, I think too. Like, honestly, something I need to start doing is breaking down these videos. Like, I plan to post this video as one big video if you want, but then also like break it down into like sort of roughly half-hour chunks based on like the concepts that we're going over. Um,
Galen, I also think there's a lot of value, like, because right now we're doing, like, we have the written documentation, but I almost think there's a value in just doing like a 5 minute, what is a monad? 5 minute, like, what is, what's a functor? Like just these concept, like, just do
totally.
really short videos, and try to do that. Because
Yeah.
like, yeah, a lot of what we've been doing is showing you how to write code and showing you how to build applications, which I personally believe that's going to help you a lot, but it's a lot to consume when you're a new user. So I can understand that. I can appreciate the feedback for sure.
And I want to add to that. I think it was kind of like in order to I think these first two sessions like yeah, yes, the sessions don't build off each other, but like these first two sessions I think are kind of meant to be like something that we can build off, where like let's say in the future we have a full session on monads or functors or something like that. We can kind of say like what's the point of this, what's the point of using functors, or what's the point of this theory that we're getting into. We can kind of say, well, like look back at like these first two sessions because you can build something with this. We're not just explaining complicated concepts for the sake of it, I guess. Like I could even see like for example like create product. um, I think this is cool. Like maybe I'm too deep in Haskell or whatever. I feel like if you like kind of squint your eyes, zoom out or whatever, you can kind of like get a sense of what it's doing. Um, but at the same time, there's so much that's happening conceptually in even
Yeah,
create product.
there's a big difference between conceptually understanding and being able to write it yourself.
Totally.
That's what I've found.
Right.
Um, and so like, because if you try to do something like this, like you're gonna like,
Yeah.
what if I just forget t.pack, right? And now there's a compiler error,
Right.
and so it's like, how do you actually, what does that mean? Why is it giving a compiler? How did I know that I needed to put the t.pack function here,
Right. Yeah.
right? And these are the kinds of things I think we'll get into in the next session.
Yeah, and I'm very convinced that we could spend an entire session breaking down create product. Like I think that would be a great
Yep.
idea, and just everything that's happening there. Like, what are case statements? What is T.pack? What is just and nothing? How do they relate to each other? You know, so yeah.
Yeah, but we look forward to your feedback. Please, if you can, do the survey. It'll be anonymous, and it really helps us because we took the feedback from the last survey into this one. So if we can keep doing that, we'll get better together. Again, like we said, this is the very start of this community. Like we're still building up momentum here. So tell your friends. But we're very much just willing to do this on a weekly basis and get this going. So yeah,
Awesome.
Lauren, we'll hand it to you for closing thoughts.
Yeah, sounds good. I'm just going to stop this recording.
Recording has stopped.
I'm gonna stop
Okay.
my